So in today's topic, we're going to look at how to calculate the relative molecular mass of an element, of a compound in an element. How to calculate the relative molecular mass. How to calculate the relative molecular mass of a compound So that's what we're looking at, how to calculate the relative molecular mass of a compound. So just like in our previous class, we have stated repeatedly that for you to be able to calculate the relative molecular mass of a compound, you must know the mass number of element that make up the compound. You must know the mass number, and as a student of chemistry, you need to know those things in your mind. Know the mass number of that element that made up the compound. So let's look at the compound like potassium heptaosodichromate 6. Let's look at the compound like potassium heptaosodichromate 6. Okay, the name of this compound is potassium heptaosodichromate 6. So let's calculate the relative molecular mass of this compound. Now, before we proceed, what is the mass number of potassium? Is 39. What is the mass number of chromium? Mass number of chromium is 52. What is the mass number of oxygen? Mass number of oxygen is 16. Is 16. So now let's proceed. K2Cr2O7 is equal to. Now let's proceed. Potassium is 39, right? Which is 39 times 2, bracket open, bracket close. What is the mass number of chromium? The mass number of chromium is 52 times 2 plus what is the mass number of oxygen? The mass number of oxygen is what? 16. 16 times what? 7 is equal to 39 times 2. We have 78 here plus 2 times 52. 2 times 52, we have 104 here plus 16 times 7. We have 112. Let's add everything together. Plus 104 plus 78. So we have 294 gram per mole. It means, this value means that for 1 mole of potassium heptaosodichromate 6, we have 294 gram per mole. That's what it means. For 1 mole of potassium heptaosodichromate 6, we have how many gram per mole? 294 gram per mole. Now, there are some students in the comment section, they keep asking me, sir, please, why are you calling this compound? Why are you calling it potassium heptaosodichromate 6 instead of potassium heptaosodichromate 7 or 8 or 9 or 10? That is a different topic. We're going to consider nomenclature. It falls under inorganic nomenclature. But for the sake of that question, I want to quickly respond to that question. Let's solve it, okay? But we're going to treat that question separately on a different topic. But let's proceed. Let's just take it. Now, This is the compound CK2C. This is potassium heptazodichromate 6. So now, during the nomenclature, during the calling of the compound, what is the, according to the rule of nomenclature, any compound that stands on its own that is not ionized, the oxidation number is equal to what? 0. The oxidation is equal to 0. So this compound is not ionized. If you see a compound like this compound is ionized, the oxidation number will not be equal to -2, and so on and so forth. You can see another compound like, nitrate is also ionized. It's also ionized. But for the case of potassium heptazodichromate 7, it is not ionized. So oxidation number is equal to what? 0. Oxidation number is equal to 0. Now, for the course of nomenclature, during the course of nomenclature, class, let's look at this together. You see potassium heptazodichromate. If you look at it, the last words you call was that, you see, potassium heptazodichromate. So what precedes the number is chromate. So we are going to make chromate the subject of the formula, okay? So let's proceed. What is the valency of potassium? What is the valency of potassium? Let's look at it together. Potassium is 90, right? 2.8 dot what? 8. 8 plus 8 is 16, 16, 17, 18, 19. 16, 17, 18, 19. So potassium is electropositive element. It tends to give out 1 electron. Potassium tends to give out how many electrons? 1 electron. So potassium is +1. That is the valency. So you have to add on the valency, okay? Don't forget, what are we doing here? We want to know why are we calling this compound potassium heptazodichromate 6 instead of dichromate 20, instead of dichromate 5, instead of dichromate 2. That's what we are doing now. So basically, before you can proceed, all the valency, the outermost electron that undergoes reaction, you are going to multiply them together. So let's go. So potassium is 1 times 2. We have 1 here. It's +1 plus chromium, because we want to make chromium subject to the formula, okay? Plus, what is the oxidation number of oxygen? -2. It's -2, right? Times 7 is equal to 0. Let's proceed. So we have 2 plus chromium plus -2 times 7 is going to what? -14. -14 is equal to 0. So we have 2 plus so plus times minus is -14 is equal to 0. Now let's make chromium. So the formula Cr2 is equal to this 14 moving across the side of the core to become positive, which is 14. Look at 2 here at the left hand side of the equation. 2 moving across the sign of the equation, the sign changes to -2. So chromium is equal to 12. Therefore chromium is equal to 12 divided by what? 2. Chromium is equal to what? 6. That is why this compound is called potassium heptazodichromate 6. That's why this compound is called potassium heptazodichromate 6. So that is how to calculate it. You can the other compounds, but the rule applies to different compounds. If the compound is ionized, the charge is equal to the charge, equal to the charge, just like in the case of potassium heptazodichromate 6, it is not ionized. So if a compound is neutral, it's not ionized, it is equal to 0 because it is not a charged compound. Or like the nitrate and the sulfate I gave an example of. So let's continue our topic, which is how to calculate the relative molecular mass of a compound. Let's look at this compound. This is nitrogen 6 oxide. This is nitrogen 6 oxide. Once again, why is it called nitrogen 6 oxide? This is the compound is called nitrogen 6 oxide, acidic oxide. Don't forget, metals oxide are pretty very acidic, while non-metal oxide, which is metal oxide are basic, non-metal oxide that was acidic. Now, this is nitrogen 6 oxide. We can use the same formula, the same pattern to get y is equal to 6 instead of 3 or 4. Let's proceed. Is equal to 0. Is this compound charged? No. Unlike this compound, like earlier, I told you about, like sulfur ion, that are charged. Sulfate ion that are charged. So if a compound is not charged, the Zwicky number is equal to what? 0. If a compound is not charged, the Zwicky number is equal to what? 0. So now, let's make n subject of the formula. It will now be n plus minus 2. Or Zwicky number first use minus 2 times 3 is equal to 0. N plus minus 6 is equal to what? 0. Now, plus times minus is minus. N minus 6 is equal to 0. N is equal to what? 6. That is why this compound is called what? It is called nitrogen what? 6 oxide. Nitrogen what? 6 oxide. Excuse me. So now we can calculate relative molecular mass of compounds. We can calculate it, and it's very simple. We need to add all the mass number that make up the compound. The total value we have in gram is equal to 1 mole of that element, which is the mass number. It's equal to 1 mole of that element. It's equal to S gram of that element, of that compound. It's equal to S gram. We can proceed. If we are told to calculate this is calcium oxide. This is calcium oxide. If we are told to what? To calculate the relative molecular mass of calcium oxide, relative molecular mass. So no. If we are told to calculate it, what are we going to do? Calcium is 40 plus 16 is equals to what? 56 gram per mole. Or you can represent it in this way, 56 gram per mole. You can get a different compound. You can get something like sodium chloride. Calculate the relative molecular mass of sodium chloride. What are you going to do? It will be 23. This is sodium chloride. So if you are to calculate the relative molecular mass of sodium chloride, we are using the same procedure. What are we going to do in this case? What are we going to do? Let's go. 23. The mass number of sodium is 23 plus 35.5 of chlorine. So 35.5, 23, 5 here, 8. So we have 58.5 gram per what? Per mole. These are how you can calculate the relative molecular mass of a compound. This is how you can calculate the relative molecular mass of a compound. Now, I am sure that in this our class, we can calculate the relative molecular mass of compound. Now, let's proceed to percentage composition. We can proceed to percentage composition. How to calculate percentage of composition of element in a compound. We are going to look at how to calculate the percentage composition of elements in a compound. How to calculate the percentage composition of elements in a compound. Now, composition of elements in a compound. We're going to look at how to calculate percentage composition of element in a compound. Now, we have sodium chloride is a compound. We have potassium heptazodichromate, what? 6 is a compound. We have hydrogen tetrasulfate 6 is a compound. We have magnesium chloride is a compound. All these respective, this is salt, is a compound, acid is a compound. So now all these compounds, we can calculate one magnesium fluoride is a compound. So you can be asked, can you calculate the percentage composition of any of the elements in the compound? We can take in this case, we can take sodium. You can be asked to calculate the percentage composition of sodium chloride. You can be asked to calculate the percentage composition of potassium or chromium or oxygen in this compound, and so on and so forth. That is what we are going to do right away. How to calculate the percentage composition of elements in a compound. Marker. Good. Calculate the percentage composition of hydrogen in the following compound. Calculate the percent composition of hydrogen in the following compound. Let's take a look at water. For example, H2O, water. Calculate the percent composition of hydrogen in the following compound. Water. So let's proceed. Now, this is the formula we are using. Percentage composition of elements over relative molecular mass of compound times 100 over 1 times 100 over 1. This is the formula we're going to use. So let's proceed. Percent composition of element, which is water. Don't forget, water, hydrogen is 2. Hydrogen is 1. Mass number of hydrogen is equal to 1. Oxygen is equal to what? 16. We must take note of that. Hydrogen is equal to 16. Hydrogen is equal to 16. So let's proceed. Percentage composition of element, which is 1 times 2. Mass number of hydrogen is 1 times 2 over relative molecular mass of water is 18 grams times 100 over 1. So we have 2 over 18 times 100. We have So we have 11.11%. That is our answer. Percent. So let's proceed. Calculate the percent composition in this compound. Potassium heptazodichromate what? 7. Calculate the percent composition of what? Potassium. Calculate the what? Percentage composition of of potassium in potassium heptaoso dichromate 6. Now let's proceed. This is the compound we are talking about. Let's look at the individual mass number. What is the mass number of potassium? Mass number of potassium is what? 39. Mass number of chromium is what? 52. Mass number of oxygen is what? 16. We need to get this in very clear in our mind before we proceed. Now, what is our formula? Our formula is percentage composition of what? Of element over what? Relative molecular mass of what? Of compound times 100 over 1, which is equal to percent composition of element. Which element? Don't forget, say calculate the percent composition of what? Potassium. So it will now be 39 times 2, bracket open, bracket close. Relative molecular mass. Let's calculate the relative molecular mass of potassium heptadichromate what? 6. Let's calculate the relative molecular mass of potassium heptadichromate 6. It will now be it will be 39 times 2, bracket open, bracket close, plus 52 times 2 for chromium, plus oxygen, which is what? 16 times 7 times what? 100 over 1. Now we have we have 39 times 2. 39 times 2. We have is equals to 78 times 100 over 1. Then let's 39 times 2. We have what? 78 here, plus 52 times 2. We have 104 plus 60 times 2. We have 16 times 2. We have what? 16 times 17. We have 272. 50 times 17. We have 2 what? 72. Two 72 104 over 1 is equal to 78 over. So let's add everything together. We are going to add 78 plus 104 plus 272. So let's start with 272. 272 plus 104 plus 78. 78 plus 104 plus 272. Times 100 times 100 times 100 over 1. So we have to cross multiply. We have to cross, yes. So at the end of the day, we have percentage composition of potassium heptaosochromate C is equals to 108.